Due to the last test partially melting the rocket nozzle, we decided to mold a new nozzle out of refractory cement, rated up to 3,000 degrees Fahrenheit to deal with the intense heat. The nozzle was additionally molded into a bell shape, which is required for supersonic acceleration in the propellant flow. As you can see in the video, the rocket begins burning at a downward slope, not demonstrating the desired flow. Partway through the firing, the flame evens out and glows brighter. Again, tons of sparks of what was first thought of as polyethylene can be seen being launched out of the nozzle. The sparks that travel the distance in a single frame are traveling at least 240 meters per second. This engine had a calculated exhaust velocity of around 400 meters per second, as opposed to the last two tests, which reached around 800 meters per second. Though 800 meters per second is over Mach 2, the gas in which it travels is incredibly hot, raising its speed of sound to around 800 meters per second, which may explain the lack of shock diamonds in the exhaust.
Interesting.
And as you can see, 3,000 degrees Fahrenheit wasn't enough. The cement was baked into glass and shot out of the engine, forming many of the sparks seen. What remained of the nozzle was a complex system of glass, cement, and soot. With our nozzle destroyed, and only one more test, we reinstalled the first nozzle and tried to see what would happen if we increased the oxygen pressure.
Go. That was blue.
Wait,
That's
what
blue.
is burning?
That's perfect combustion. Here we go.
So, a lot of things happened very rapidly, and we're still putting all the pieces together. First off, the rocket performed quite poorly, producing only 0.3 of a Newton. A constricted nozzle seems to be necessary for higher thrust. However, the energy that did not go into motion went into heat. The nozzle glows red hot as it passes 1000 Kelvin, and then white hot as it peaks somewhere between 2,500 and 3,000 Kelvin. Then, blue flames break out. There are two theories to how this happened. One, the oxygen leaked through the pipe and started burning the soot with incredibly high efficiencies. And two, the galvanized steel itself caught fire, and the burning of a certain chemical in the metal produced the blue flames. Afterwards, a powder was left on the edge that quickly oxidized. The nozzle was glowing for a full minute after engine shutdown, and had a blob of solidified metal sitting on its edge. In order for us to build faster and more powerful rockets, much more advanced cooling and pneumatic control will need to be constructed.